Hello friends, today we are gonna talk about bicycles, and with that we have a special guest that will introduce himself in a second. We have
So I'm Kastik, and I work for SRAM, name of company for which I work. It's right here. So SRAM makes electrical, mechanical, and electromechanical components for bicycles, professional level, and also for e-bikes. Yeah, so I work as an embedded systems engineer, mostly on electronics for the bikes, but also participate in different reviews. Like I work closely with mechanical engineers who do all the mechanical parts, etc. Yep.
okay. We have a list of questions here to ask him. So let's start with the first one.
How do you make a bicycle frame strong enough to hold a person and yet light enough to ride easily?
Yeah, so bicycle frame is made like human's bone.
Oh.
So it's empty inside, but the matter is outside. So it is as strong as you have like a solid piece, but at the same time it's super light because it is filled with air, with nothing.
So it's like a hard shell with nothing inside.
Exactly right.
So a hard shell that is strong enough, very strong, but
Light.
Yep.
because it has nothing inside.
Yes, that's
Yo.
one way to do. Also, like usually bike frames are made with metal alloy of different types. More advanced frames, they are made of fiber carbon. It's like plastic. It's
Yeah.
very light but
Yeah.
super strong. In drones, in helicopters, they use this material to make blades. Very light, but very strong. So that's like, yeah.
I think I heard of it.
I think no, the material is used for lots of things.
Exactly
Like
right.
there's baseball bats that contain that material.
Yep, I did not know this. Thanks for now. Now I
Yeah.
know. Yep.
Now, next question.
Second question.
What makes a bicycle more aerodynamic?
So bicycle aerodynamics is more about tires and about the wheel tire.
Yeah.
So bicycle itself, aerodynamics is you cannot do too much. But with the wheel, the way we design wheels make it stable. And actually there are different types of the wheel for different like competitions, depending on which trail you ride. If you ride a nice and paved trail and competition, for example, for speed or for time, there are different goals and they use different wheels to achieve different goals. For speed, you use one type of wheel. For example, riding on a trail, bumpy trail, you use another type of wheel. That's what
Makes sense. Makes sense. Makes a lot of sense.
There might be thousands of categories.
Yeah.
Yeah, usually it's like 2 or 3 types mainly used. One is for high-speed rides, and they have very thin wheel, very thin tire, and those things that keep the tire, they are kind of like flat,
Yeah.
and they are everything is very thin, so the resistance to air is minimal. Also, when it spins, the way the tire is designed so that air will keep it stable, will prevent bouncing of that tire back and forth. So that's how they design different wheels and tires for different goals. Yeah.
So it's like it's designed to make that.
Yes.
Wow.
Yeah.
Yep.
Yeah. Different wheels equals to less or more fast.
Yeah. It's
speed.
speed.
More speed.
Time, it depends on the competition, it depends on what trail you ride, things like this. Yeah, but it's not about the bike itself. It's more about tires and wheels, rims. Yeah.
Oh.
Third question.
Third question right now.
Why is it important to check the tire pressure on a bicycle?
Yeah, so tire pressure is very important because for safety and to make sure the bike is stable. So if it's underinflated, the bike stability is a
Yeah.
question. Yeah. So, and also it's a concern for the tire. It's easier maybe to punch it, so you can damage it easier, depending again on which trail you ride, either whether it's a nice paved trail or it's on road bikes, like a different story. Yeah, so the tire must be like more advanced bikes. They have tire sensors. They monitor tire pressure all the time. And if one tire has like pressure underinflated or overinflated, you will get a signal, like notification from that sensor,
Oh.
hey, adjust the tire pressure. But all this is only used by professional riders or professional enthusiasts.
Oh.
Yeah.
Very advanced.
Yeah.
It is.
I didn't know bikes could do that.
Yeah, it's like on a car, like a modern car, they have tire sensors on all four wheels. If you punch one and it's like lose pressure, you will get a signal. Same for the bikes. Yeah, but it is very important to keep the pressure right for stability and for safety.
Okay, next question.
What are some of the latest innovations in a bicycle technology?
Yeah, so the latest, there are a lot of them actually. So first of all, I work on suspensions. Suspension is equipment, device that absorbs all those bouncing, all those, when you hit the bump, it will absorb the energy. So your bike is still stable. You don't feel all those like on a car.
Oh.
So advanced suspension, it can actually monitor terrain type. It can detect bumps and adjust the stiffness. So electronics can control the valve in the suspension and actually make it softer. For example, when you ride the bumpy road, you want suspension to work softer, so it will absorb all these bumps. Now, when you ride the paved road, you want suspension to be what we say locked, like more stiff. So, in which case, to prevent those unnecessary bouncing when you ride canyons and valleys. Yeah, so that's one advanced technology to dynamically adjust suspension characteristics to adjust to the terrain that you ride, to trails, to paved or unpaved roads. Yeah. So another advanced technology is like for the seat post. So you sit,
Yeah.
right? So you can control the seat. For example, when you go down, you want the seat to be high.
Oh.
So for aerodynamics, okay, and to balance the weight.
Yeah.
So advanced bikes allow to press the button, a little bit go up, and then seat post will actually extend. So when you again press the button, you can readjust it and remove it, and it will stay at this level. So it allows to dynamically change the seat post. That's another advantage. Other advantages are sensors. A lot of modern bike has a lot of sensors, like I told, pressure sensor,
Yeah.
pedaling sensor, torque sensor. It can measure your effort, how hard you pedal the bike. Professionals need this information to adjust during competition, so they can prepare better for the competition. They collect all the information, the cadence, the torque, the pedaling speed, bike speed, by the way, all those things. Yeah, so bike, yeah, it's like a modern car now. Yeah.
Doesn't the button of rising the seat distract the driver?
No, it doesn't, because the rider wants this. So for example, the rider wants to extend the seat post. He will a little bit stand up, press the button to release the valve, and then using the air pressure will adjust till that point.
Yeah.
Release the button and it stays. It locks. It changes the valve position and it is locked. So now the rider can ride with this seat post, for example, extended. Now, for example, you go down. You completed descent, now you go up. You want seat post to go down again to balance the weight on the bike during the ride. So you press the button again, put a lot of weight, so it will retract, and then release the button, it stays at this level, so you can continue, for example, ascent. That's how it works. And there are many other things, like we're working on wireless things, so you have wireless controllers on both sides. So using radio channels through the radio, like your Wi-Fi or Bluetooth, it talks to other components, for example, shifter. The bike may shift like gear 1, gear 2, gear 3. Like in a normal bike, you will have like a wire connected to this shifter, and you need to now
Oh.
the professional bike, it's like wireless connection with the electronic module that actually does those shifts for you
Throws a signal.
through the signal. So it's battery powered like a handlebar with two buttons. For example, one button to adjust the seat post, another button, for example, to do shifts in one direction, for example, gear 1, 2, 3, 3, 2, 1. So you press it multiple times through the radio channel. It sends the signal to the derailleur that controls the motor that will do this shift. And it's, yeah, that's a lot of advanced things.
That's kind of complex.
It is, and the bike with all those components costs $9,000. It's more than a car. Yeah, those components are expensive, but this is for professional riders, for world championship, like competitions, things, and for enthusiasts, of course. Yep. So also like SRAM, they participate in many programs, like in many events. My company, they sponsor competitions. They sponsor sportsmen like to provide like so they can train and then participate in those competitions. They also participate in Bicycle World Relief program. That's the number 750,000 bikes were donated or provided to poor people. So people all over the world, instead of like riding the bus or driving the car, can use bikes to get to the job, to university, to school, for groceries, to park. So company tries like to push more to participate, to contribute a lot, like to spread bikes all over the world, for many reasons. It's good for health, it's good for nature, so we spend less gas, better. Yep. So
the one who does that is a genius. Yeah, yep. More bikes, less cars. Less cars, less pollution.
Sure.
But also there's electronic cars that are better for the environment.
Yep.
But also the bikes are better for your health because you have to use your feet, your legs, your hands.
Keep straight.
Keep straight.
Posture.
Yeah, the posture and stuff. So more bikes is better.
Use bikes.
Use bikes.
Use bikes.
Use bikes.
Use bikes. Sure.
Yeah. Use bikes.
Next question. What are some of the challenges of designing and manufacturing bicycles?
Yeah, so there are a lot of challenges. First of all, reliability. Components that we make must be reliable, and to guarantee this, we need to test them. Testing takes months. Like, for example, suspension component, we put it in special machine that will mimic what happens on the bike. We'll push it back and forth, hundreds of thousands of times. And then after 100,000 times of those cycles, we will check each component of this suspension, spring, air, like valve inside the chamber, air chamber, everything, to make sure no cracks, no internal damage, nothing is bent, it works reliably. So testing takes a lot of time and a lot of money. So that's very, very challenging, because for every new component, we need to design a new test machine. Some of them can be, we can adjust to work for different products, but usually new product, new test equipment, it is very expensive, and it's time consuming to design this machine and then to use it to test all those components. Testing takes longer than actually development of the product, design of the product. Yeah, so that's one of the most like challenging things, especially for pro level bikes, for professional level bikes, because they are used under very high stress during competition, during those rides, like like mountain bikes. If it fails, the rider can die, can break something or whatever. So it is a big concern, and that's the most challenging thing, to test and to ensure things work right for life.
Yeah, because if a component works works, you think it works, but you didn't test it, but you're very sure that it works, and you sell it and it doesn't work, someone could hurt himself or even
And
cause
Yep.
great injuries like death.
It's company reputation, all those warranty returns, company reputation goes down. We cannot allow this. It's also like you told, like the rider can break something, can get injured, and that's again, if we are responsible for this, we will need to pay for that, for recovery or whatever. So it is a big challenge here to make things reliable, especially for those pro level bikes. We also started working on e-bikes. SRAM just entered e-bike industry. We started making components for bikes with the batteries and the motor, things like this. So that's another challenge because, yeah, we never did this before.
Yeah, because a new entire product takes a lot of time to make.
and money,
And
Money, time, money,
tests,
tests. Yeah, so new products usually take a lot, but a lot to do,
and time.
and times. Yeah,
How do you make sure that bicycles are safe and reliable?
Yeah, again, like I told, it's during development, mechanical engineers put a lot of effort, like using previous experience from previous products. We collect, when product fails, we collect a lot of information from that failure. We will do all sorts of analysis. We will cut that component to many pieces, use electronic microscopes, whatever, just to root cause the problem. Then we put it to our database. So next time we develop something, we use this experience not to repeat mistakes again and to prevent this from happening. But mostly this is done through testing, through extensive testing of the component. If something fails, we redesign things. It goes back to mechanical engineers. They will try to change something, to adjust something. And it many rounds, design, prototype, test, something fails, goes back to change into the design, again test, and so on, so far. Yeah.
So I heard this one sentence that says, "Mistakes makes you strong."
yeah,
That's
Kind of like
absolutely true. We also use, even though like we have competitors, but we usually share those mistakes. It's same like they do for spaceship, between like for to explore in space. Every mistake that happened to, like, for different program from different country, they try from time to time. All those scientists, all those engineers come together and talk about those mistakes and then try to prevent them from happening. Similar to bike industry too. So we share our experience, try not to repeat the same mistakes again, but again, because of a lot of challenges, things happen, then we try to fix it, and so on.
yeah. You have to tell another companies, your competitors, so they don't make the same mistake as you,
Yep.
so they can be a bit faster at componing and do not make the same mistake, so it sells and something bad happens.
Yep, this is done through like a summit when different companies from bike industry representatives come to like summit and they talk couple of days, just discuss things, report things, and it helps kind of like to, of course, though they are our competitors, we cannot share everything, but certain things we share and they share their problems too. So then we can exchange experience and make products better. So everyone benefits from this. Yep.
Yep. Next question.
at
This
what-
is this is the second to last question. So just wait until the end. Yep. Next
what-
question.
At what age you gain interest into bicycles?
So that's interesting because I never worked in bike industry. So SRAM usually hires people who are enthusiasts are fans of riding bike. I had zero experience, almost zero. I know how to ride the bike, but I'm not a professional rider, a professional, like, cannot ride very sophisticated trails. But I had a dream. I wanted to work, doing hardware and software development. In the United States, it's usually very hard to find one job at which you can do both things. You will need to select either one or another one, either write a code or do hardware design, like component level design. So in SRAM, they had this position. And I applied for this position. So I told them that, hey, that's my dream to do both things, even though I'm not a rider, I'm not a fan of bike riding. So, and they hired me for this. But of course, after I joined the company, I started to ride a lot. So we have bikes that we can use there, like in the office. So we use them for test rides. So we make some changes in the product. We put this product on this bike. Then we do rides. We have nice trails near the office in Colorado Springs. A lot of trails of different types. So we test those bikes, come back to the office, make adjustments, and then do it again. That's when I actually started to ride more and more. Hopefully that answered your question. Yeah. So I would say in my 38-year-old, I started to ride more and more. Very late.
Yeah.
Yep.
Yeah. Let me read the last question. How often do you ride bikes?
Almost every day at my work. Sometimes I grab the bike to ride around just in a park, just for pleasure. I do not have my own bike, but I can always borrow from my job, so I don't really need one. But I try to ride well, if not every day, but maybe every next day, and usually for work. Yeah.
Yeah, that's the last question.
I hope you liked the interview.
Absolutely.
And really hope you like this video. Subscribe, hit the like,
comment the best part of this video,
and hit the notification bell so you don't miss any of our videos. And yeah, that was the interview. Really hope you like it.
Absolutely. It was my pleasure. Thanks a lot.
Thanks for accepting the invitation.
Yeah, thank you very much. And this was the video, and bye.